Find equation of quadratic that has a maximum value of g of negative 1 equals 6 and goes through the point g of negative 3 equals 4. Well, what does this mean, a maximum value? Even before that, equation of a quadratic. When we graph a quadratic, what is it? It's going to be a parabola. So a parabola will either open our parabolic functions here, up or down. If it opens up, then this point is a minimum. And what is that point called? The vertex. That's our key point there. If it opens down, this is a maximum. So what this is saying is the maximum value, g of negative 1 equals 6, this is telling us our vertex. So what is negative 1? Remember, this is function notation. This says x equals negative 1. And then g of negative 1, which is our y, will be 6. So this is giving us a vertex of negative 1, 6. We can write this using our vertex form, which would be a comma x minus h squared plus k. So we can plug that in. Y equals a times x minus negative 1, or in other words, x plus 1, quantity squared plus 6. Are we done yet? No. What this is it gives us all of the parabolas that go through the point negative 1, 6. We know that a has to be what if it's opening down? A has to be negative. So when we find a, it better be a negative number. How do we go about finding a? We're going to need some other information about this parabola in order to do so. Do we have any other information? Yes, we do. We have this. This is telling us that x is negative 3 and y is 4. Well, if we plug that point into this equation, that will allow us to solve because a will be the only thing left. So let's do that. A times negative 3 plus 1 squared plus 6. So we can move the 6 to the other side. We get negative 2. A times negative 2 squared. So 4a equals negative 2. And I'll come back here and say a equals negative 1/2. Now let's write our equation. Y equals negative 1/2 times the quantity of x plus 1 squared plus 6. Now, really I should not be using y. The problem said g. And so let's change that to g of x equals. And that's it. Next one, find the equation of a quadratic function with zeros 5, negative 2, and through the point 1, 6. Now let's think about this. If it has zeros, what does a 0 mean? First of all, the 0 of the function is where f of x equals 0. So we have points 5, 0 and negative 2, 0. What else do you call those? Those are our x-intercepts. When we solve and we set this equation equal to 0, we get these solutions. X equals 5 and x equals negative 2. Well, if x equals 5 is a solution, what would be the line that came right before that if we were solving? It would be x minus 5 equals 0. Similarly, this would be x plus 2 equals 0. What would have come right before that? X minus 5, x plus 2. Now we're close here. If I had this equals to 0, then I could go through this process and I would get 5 and negative 2. But there could be a coefficient here. Do we know what that coefficient is? No. That's when we use a. Now, how do we find out what that a value is? We're going to need some other piece of information. I'm going to erase the 0 because we don't really need that. I was just emphasizing how we are getting that. So we have f of x equals a times x minus 5 times the quantity of x plus 2. In order to find a, we're going to need a number for the f of x and we need a number for the x. Do we have it? Looking at the problem, it goes through 1, 6. That means we can plug this in. We have a, 1 minus 5, 1 plus 2. So we have negative 4 times 3 times a equals 6. 6 equals a times negative 12. So a is negative 1/2. I don't think I did as good a job picking my problems on this one or making them up. So we can just write the equation though. F of x equals negative 1/2 times the quantity of x minus 5 times the quantity of x plus 2. And that is our equation. That's our quadratic function with zeros 5 and negative 2. Going through the point 1, 6.